All right, great. Thanks everybody for being here. We will go ahead and get started right away here. Get this going. All right, in our topic today, we're actually going to be visiting quite a bit of 2D and 3D. So we can actually see what's physically going on between the two different softwares, the electrical schematic package and the 3D package. We've got a lot of, because of the dynamic updating that we were talking about last week, you could actually see how everything was working between 2D and all the different schematics and how that SQL was working. Well, it also does the same thing when you get into the 3D environment. And so what you end up having is a lot of correlation going between the two that allows you to be able to see what's happening, especially when you get into a multi-user environment. You will end up starting to see things that are happening in your 2D environment, and if you are using the 3D environment as well with other users, they will start seeing those same changes as you're making them. So you end up having a lot of easy access to information as far as that manufacturer's metadata and all that good fun stuff. It's all going to be tied back in even in the 3D environment. So you end up having quite a bit of availability to create and design right away. So let's just jump right into the 2D schematic. And as you remember the circuit that we were working on, you had these motor starters with the disconnects and the circuit breakers and everything here. This same thing that we were talking about with your componentry that you've got on the left-hand side also translates directly into the 3D environment. So if I jump into the 3D environment here, let me grab that real quick, you will see that under a specific location, I have those same components that we were talking about previously. Now, when you start working in this way, you can actually take all of these components very quickly, very easily, and drop them in. Now, as you can see, I have check marks here. These check marks are referring to what is already installed. So if I were to click on any one of these devices, it shows that it is physically installed. However, at the same time, the information from the electrical, I can actually bring up and see the information that is happening in the 2D environment. Not only do I have that preview that I had shown you last week over here on the right-hand side, where you could actually see the entire project and what was physically going on with the project as far as the designers showing a specific schematic here and being able to design that. I can do that same type of thing in the 3D environment here where I can preview it, but at the same time I can design in my 3D environment and have multiple users working on a specific project at a time. So I'm going to go ahead and just continue here, and I'm going to hide all the components that I've already installed so that way I don't have to worry about them. And here's my working list of things that I still have to install. Some of the neat things here, you can reorganize this type of information. Now, mind you, I am strictly in the 3D environment here. Nothing major going on other than the fact of what I am doing in my 3D assembly. But I'm building my electrical cabinet in the 3D assembly. So therefore, I am creating my cabinet layout, and I don't have to do things twice. I don't have to create it in a 2D schematic, because what I can do is I can actually take this and I can make this into a drawing, which we will look at a little bit later. But for right now, you can see I can place one device at a time, or I can insert multiple devices at a time. What is really kind of nice here is that if I am working in a 3D model, when I am creating this assembly, I am working in just the 3D model. What I am referring to here is that if I were to take this device and delete it, when I delete it, I am not deleting it from the project. I am strictly deleting it from the 3D assembly. As you see, the model is still here. It just needs to be reinserted. So if we are looking at that, what I'd like to explain is where this 3D model is coming from. Because as you saw when we were in the 2D, as well as these properties here, you have the capability of either selecting a 3D model of your own, or you can assign one. And that's strictly in that manufacturer's database. We have here a 3D model. It has a 3D part assignment. You can get this from your EPDM if you are using a data management system. You can create that 3D model from something that you have just on your laptop. It's just a matter of browsing for it and then grabbing what you are looking for to assign here. And then that 3D model is available utilizing the dimensional aspect of your circuitry here. We have the dimensions here. These dimensions will then take that 3D model and shrink it down or expand it out to this dimensional requirement to make it correct when you are actually utilizing it in your 3D environment. The same holds true even in your 2D environment where you are doing a cabinet footprint. It is going to do the same type of situation for you, but what it's going to do is allow you to be able to make a generic symbol and just drop it in, and it will adjust all the dimensions for you. So with that, let me see here if there was anything else that I wanted to go through in this area. Dennis, do you have anything further to add to this specific section?
I think you covered stuff pretty well there. It's a great handshake that happens between the two environments with a lot of flexibility. So let's recap, and then we'll put out another poll question after that.
All right. So as you can see, we get into the user environment where you can definitely utilize things back and forth. It eliminates auditing when you are working between these environments. You're not having to do those design meetings. You're not having to worry, did I tell so-and-so that I actually changed this? We will get in a little bit further into that when we actually get into the next section. When we start assigning some manufacturers data, you will see it go back and forth. But it ensures that every user is using the same data, including the parts and symbols that you're going to be utilizing.
Very good points. And our first poll question kind of goes in that direction. Let me put that up here for everybody to reply to. Again, this is multiple choice options, so I know that some of these things might, a few of them might apply to a number of you in how you work today, and asking exactly how do you develop this list of components for your project. That list that Sherry's been talking about, it's problematic for a lot of customers that we talk to on keeping it up to date between the electrical and the mechanical departments and the information that's getting ordered and put out to the shop for assembly, out to field service for updates, etc. So we'll look for, everybody looks like they're filtering in there. I got just a few more people maybe to reply, and then we'll shut that down and share the results with you on this one. Give it a couple more seconds if you haven't replied. Ask you to quickly do that. Okay, I'm going to close this, and let me share the results with you. So this second option is what we find from a lot of folks that we talk with, that each department tends to be responsible for the components in their area of expertise. So electrical dealing with the panel items, and the mechanical group with the various mechanical components on the system side. There's that crossover area, though, where sometimes it's a little bit of a gray area, right, Sherry, like a motor or a sensor or a switch.
Oh, anything that's out in the field seems to be questionable as far as who's ordering the parts, especially if the component has a pigtail where you are having to deal with the fact that it is truly an electrical component, you know, where some of the other ones have the screw-in type Turk or Brad Harrison's. Then it becomes a question of, well, who's ordering the cable versus who's ordering the switch? And in some cases it's mechanical, in some cases it's electrical.
Yep, that's the challenge that every company seems to face, is where do you draw that line? So let me hide this and we'll get back to the presentation here. But as we roll through with these questions, at the very end we'll give you some benefits on how, kind of roll all the benefits together that Sherry's mentioning and what this means to your organization as a whole moving forward with a solution like this. So Sherry?
Okay, so once we get into modifications, we get into another whole animal itself because, of course, as you know, any change in the software becomes a change that you have to deal with, making sure that everybody else is familiar with it or that everybody else has changed their devices as well. And so you get into a big mess once you start having to deal with that because then, of course, you're dealing with a lot of different time frames here that everybody is, of course, having to change things, and how much time does it take, and did you audit this, and had you changed that, and it just, what a mess that becomes. So what we're going to do here is we're going to do just that. We are going to take this motor starter, this 90, actually let's take this 820 since we're always working with this 820, and what I'm going to do is I am going to 3D environment. Maybe I am, whether it's a motor or a motor starter, maybe I'm going to, in midstream of designing here, I am going to change this motor, and I am going to change it to a new motor, or a new motor starter. So I am simply going to delete this motor starter and search for something new. Now this is actually going to be transferred into another, what am I trying to say? This is actually going to be changed into a different manufacturer completely here. So when I do that, what's going to end up happening is that this information now, of course, if you were doing this manually, you would have to look for who do you have to change, or who do you have to tell, how many people do you have to tell, how many meetings do you have to make sure that everybody audited their system correctly. You end up starting to have all kinds of issues. So we're going to select this Legrand here instead. And so this information now is just slightly different. It's going to look a little bit different here because what it does is it automatically knows that I have changed the 3D model, so maybe there was a difference in size. So it deletes it from that assembly, but what it also does is if I go back to my electrical for that 820 motor starter, what you will end up seeing is that 820 is right here, and I'm going to go to the symbol property now and actually look at that manufacturer, and you can see that it is Legrand here. In the 2D environment, it updated everything that we were talking about. It's going to do it as a cross-reference. So if you remember those hyperlinks, we can simply go to that, the cross-reference, that hyperlink. All of this motor information, the motor starter information, has now changed based off of what is physically being used here. So you're using it back and forth. Simple things like even deleting this here. If I were to delete this circuit, oh, I guess I deleted two. Don't really have to worry about that, but I'm going to go back here to my other one. And what you will see is that I am losing the information now for that coil. It is no longer the coil available for that design. So you still have the issue, of course, because you're using part of the circuit, but I'm going to go ahead and delete this circuit completely, which means that it is no longer, see where else am I using it? Well, I'm using it on sheet 5. So what's really nice is it's very easy to tell where I'm using this type of information. I'm going to go ahead and just delete these pieces completely. So I've got a second one there, and I also have a motor starter right here. And what I'm going to do is delete those completely. When I've deleted that circuit completely now, those components, I am no longer have an 820, as you see. I can just as quickly go back to my SOLIDWORKS and look here, and 820 has been removed. So it is no longer there for any type of functionality whatsoever, if the 3D design as well as the 2D design. So you end up having issues where you can deal with certain things that if you had, just like I was in my schematic, when I go back to my schematic here, there was also another way that I could do this, which would have been that design rule check that I believe we've talked a little bit about with the auditing, that it would show a specific report and whether I had actually used all of the components or if I was missing a part assignment, or if I had changed things. As you can see right here, I do have some components that have not been assigned. So that does automatically update because it's just a picture update space. It automatically updates right away. Okay, with that, I'm going to take that back now to here, and you can see that the improved communications across the design teams, being electrical has never talked with mechanical unless it's a forced design review meeting. Now all of a sudden you have this dynamic update which is happening, so mechanical can proceed without having to stop everything they're doing, have a review meeting. The auditing takes place of anything manual that you would have to worry about, and make sure that you do not have to go back through your drawings, thus reducing the amount of time you need for design reviews. You can spend more time designing and less time worrying that someone else has not picked up on your changes. Dennis.
Good stuff, Sherry. I think communication is one of the key aspects that we bring to the table with this solution. And our next question is going to be along that line. Let me launch that poll here. And what we're asking you to do is, again, this is multiple choice. And how do you currently check your electrical design projects between groups today? And maybe it's just done singularly in your electrical department, or do you have to do that jointly between departments? So if you'll take a moment and reply to those polls, we'll leave that up here again for about a minute and share the results with you. And some of this also is going to speak into other areas where we start showing you a few more of the audits here as we go forward. So keep this in mind as you look at some of the upcoming topics as well. All right, looks like we're just about done here. I'm going to close down the poll here in 5 seconds, and we'll share those results. 4, 3, 2, 1, and let's share that. And so probably, again, a fairly common trend that we see as companies get leaner and more efficient. The responsibility of doing this type of checking is on the actual designer themselves. And option number 2, I was going to be surprised. I've only heard a couple of times over the last 5 or 6 years that there are still dedicated checkers in a given company. So that seems to be a career path that has gone the way of the, I don't want to be so harsh as to say dinosaur, but I can't think of any other analogy there. Can you, Sherry?
Hey, I used to always have to check my own designs. It was never somebody else's responsibility. It was always mine. So, yeah,
yep.
I have
to never
really
gets checked until it gets out to purchasing or the shop floor, right?
Yeah, well, yes. The shop floor always seemed to check inadvertently because, of course, as they would design, they would come back. And I, unfortunately, am not one of those people that could honestly say that my design was 100% proof, you know, the first time. There were always some red lines that came later, and,
yep.
Yeah, it happens.
I'm going to hide this poll and let you get back to it. And I know from my past experience, there was nothing quite as much fun as having somebody from manufacturing come in and tap you on the shoulder and say, what the heck were you doing on that day, and how did you overlook that?
Yeah, nice.
Yeah.
Okay. All right, so let's get into the 3D design just a little bit more here. And what I'm referring to is we're going to get into if I were the mechanical engineer and how it's going to relate back into the electrical. So let's go ahead and grab my 3D model here. I guess I have to actually grab the 3D model. I'm going to do one quick thing here first before I finish up, just before I forget about it, just because we will use this here in a minute. So I will go ahead and finish this installation. But what I am going to look at as soon as this is done is the actual 3D model. Because the 3D model, if we are in electrical, the 3D model is actually what is everything is driven by. You have here, as you can see from the left-hand side, a complete assembly. And this complete assembly actually has not just the enclosure, but it was also some components that are hidden, like the rest of the conveyor system that's actually in tune here. It's a palletizing conveyor that has other control panels. It has other conveyors. But we're going to be looking at just this one because what we're going, as a mechanical engineer, we're designing. He's going to be placing specific devices, and those devices could be including what we have here, this electrical motor. He is responsible for possibly placing it, so he would drop it in. That electrical motor, though, as an electrical engineer, I know is part of my design. So what I would like to do is once my mechanical guy has finished with this, I will come back through with electrical. And I will actually look at the fact that this motor should be motor, what do we have here? We have motor 614. This motor has not been placed yet, but I know that this 3D model is what I want to be assigned to that. So what I am going to simply do is right-click here and associate my electrical to the 3D model that the mechanical engineer is working on. When I do this, that information now molds together. It now becomes one device that is now utilized through both. Now, the second half to this, however, is the fact that I am going to want to route the cables. Now, because I have now associated that motor to my electrical, I can actually route the cable directly. If you remember from our circuitry, we had that circuit that was here, and I'm going to look at page 6 real quick. 614 motor is right here. Oh, look, we don't have any motor starter anymore. I guess I should put something back in there, but I'm going to leave it off, and we'll just route the cable anyway, because what I am concerned with is this cable, as you can see, goes still from this motor strip, from the terminal strip, to the motor. In the 3D environment, it now recognizes that. So I will go ahead here and just simply tell it to route cables. When I route the cable, what it's going to use is a sketch that I have created in the background. Let me show you that real quick, just so that way you will actually see it. We cancel that. And we have this EW path. It is a 3D sketch. You can see it highlighted here in blue. It does not need to go to all the devices. It is strictly something that is used for both the panel to know where it's going to be routing. And, of course, this looks a little bit funny in the 3D environment, but you can see it on the door here, that what it's going to do is it's a dimensional 3D sketch that will now have wires follow these areas in order to wire up. So what ends up happening is that I can very easily then tell my cable where to route. And so it's going to simply select that area here, and I'm going to go ahead and tell it to route the cable. And it's going to pick up that 3D path, and it's going to route the cable to that. Now, as you can see, you can start seeing it, looking at how it's going to route it, and it's looking at connections and all that good fun stuff. But now what you can actually see when it is complete here, let me zoom in on this, that we have the connections coming from the cable and connecting up directly to the pins in the pot head for the motor. And it goes through the cable tray, and what it's physically doing is then going to the actual panel here. You can see it coming up through the panel. It goes through the cable gland, and then it's coming up through to the connectors, to the terminals for the connection point. So it's getting all of that from the 2D electrical environment. If I look at my 2D environment, what you will also see is that I have a length now for the cable. That cable previously had a 0 length to it because as far as I was concerned, I wasn't worried about manually putting in a cable length. Here is my list of cables. Here is W10 with a length that is in inches of 393 inches and 1/2. This is coming directly from the 3D environment. So very quickly, you can see how you can start working with these pieces and at the same time not have to worry about measurements, not having to worry about things on the ground, not having to worry about any type of other device to help you figure out lengths for cables, for all this information. It is going to simply just be there for you. So I'm going to go ahead and simply do the same type of thing in the cabinet. Now, most people have cabinet builders that build their cabinets, but at the same time, some of them actually do it out on the floor. And I have been asked a number of times, is there a way we can actually give them a picture of which way you would like the wires routed? Because they want the segregation. They want to make sure that these wire ducts do not get overfilled. Or maybe they're worried about attenuation between data highway, any type of blue hose, Ethernet that's too close to 480 wiring. You can actually segregate that out in the 3D model and then give a picture, even a PDF for this, just by creating an actual drawing. You can give that information to these people very quickly. So we should be cleaning up here in just 1 second as soon as it finishes up. And then we've got some a great way of being able to actually see this information at your fingertips. So here it is right here now. I'm going to zoom out and then zoom back in. You can see that the PLC is wired. We have the cabinets. The disconnects are actually wired directly into these components. And it's nice and it's a clean cabinet. It is not like you have to worry that it got crossed or anything along those lines. And that is where I'm going to end the demonstration. So I'm going to come back here and just show you some of the benefits that we do have here. So we've got some faster time to market due to that decrease in the design time. At the same time, we can eliminate costly mistakes, especially if we get 2 different part numbers, one for mechanical, one for electrical. You do not have that issue here. And at the same time, you can get automatic calculations of cable length, wire length, you name it. All right, Dennis.
Sherry, good stuff again. One thing I wanted to point out, and I don't know, it's kind of a subtle thing, but it's kind of powerful as I think about the marriage of these 2 environments. You took the information on the 3D side to assign to that motor. It could just as easily have been done by the electrical engineer over in the 2D schematic. But both of those sides are communicating with one another, and you're able to look at what's been assigned and what hasn't. So as we talked early on, sometimes it's certain people on the mechanical side that are responsible for a set of information to be filled out for components. Other times it's on the electrical side. The software really gives you that flexibility to work whatever way your company is structured to work in that regard. So I don't know if everybody caught that. That's something, took me a couple times to see in your presentation before I kind of caught that subtle little move there.
I have a lot of subtle moves, Dennis.
You do. It's all smooth, Sherry. It's all smooth.
All right. Okay.
Well, our last poll question here. Our last poll question for everybody. How do the mechanical electrical design teams share component information today? So again, this is a multiple choice, and in some companies, several of these methods might be applicable. Feel free to share with us how many of them that you guys go through, and we'll let that wrap up here for another few seconds or until I see everybody's voted, and then we'll share those results with you. And one of the other things I don't have in my wrap-up that we're going to do next on benefits, but it's something that you just illustrated as well in this last section. We don't get a lot of folks in the past that have really seen the value of automated wiring. And it's getting a little more popular because more and more companies are finding the workforce out in manufacturing that's done this in the past is starting to retire. And there's not that new generation of folks coming into the workforce with that tribal knowledge to go and lay these things out. And also more companies are getting to where they've seen actually routing a cable or a pneumatic or hydraulic line in a particular path has a lot of value with regard to creating duplicate components or systems, as well as maybe some engineering benefits to how that particular circuit's going to operate and perform. So we're getting more interest in that area. I wouldn't say it's every customer that's looking at this, but it is becoming more popular for those reasons as well. Looks like we're done on the voting. Let me close that and share the final results here for you. So we've got a couple of things, and we'll be talking especially about the last item, a combined bill of material, in one of our future sessions. So stay tuned for that. Project review meetings and spreadsheets most often tend to be the way that we hear. There's still a fair amount of people that do take project prints and mark them up between departments and customer meetings and so forth as well, though. So with that, I think I am all set. We'll hide the poll and bring up our last wrap-up slides here. If you kind of take back these benefits and features that Sherry's been highlighting, kind of the overreaching umbrella that we would encapsulate all this under is improving, again, productivity in both your engineering departments, both electrical and mechanical, and allowing you to better communicate between those departments as well as throughout your company in manufacturing and purchasing, so that you're able to deliver your systems faster and on time. So that becomes a key factor for your sales group and your operations manager. The faster that you can deliver a product, the more products that you can theoretically do in a year. That seems to be a goal for a lot of customers these days. The economy is turning around and folks have been downsized, and the question of do you add more people or do you try to improve productivity is kind of on the forethought for a lot of management people these days. So I think if you go to your management team with this type of a message on how you're able to save on the cost of operations and also improve the customer satisfaction, you're probably going to get some attention with them. And how we do that, Sherry's been talking about this throughout the presentation. We improve the communication between these different departments within your organization as well as with your customers. Having a 3D model to review is something that more and more customers are finding to be a significant benefit. It shows that you're technically savvy with your customer, brings you more credibility as you start to talk with the engineers on the project from your customer's end, when they can actually visualize how you're going to lay something out and wire it all up in advance of actually doing it. It gives them a better sense of security. Of course, all those things help to reduce potential ECOs that come up when everything starts coming into the shop or it gets put out to the field. You're going to catch more things up front in engineering, which is where the trend in productivity tends to be these days, trying to catch more of it up front where it's not as expensive, rather than out in manufacturing when we have parts that have to go back or FedExed out to a job site. We saw a little bit of the automated design checks. We saw some of that in our previous session, and we'll be doing more of those down the road here as well, on how the system takes that human factor out of the equation and helps you automate so that you don't have to spend time doing that type of work, but instead you can focus on your designs. And of course, all of these items, again, tie back to reducing risks in manufacturing delays. So as I mentioned, we don't have a final survey or poll question for you. Instead, we're going to send out a survey monkey to the folks that have attended. We'd ask you to rate us, be very critical on how the presentation went, the quality of it, as well as the content. And if you see areas that we can improve, we certainly want to hear that from you. Our goal is to always be improving here. As well as the other areas, we're going to continue to ask what other areas we'd like to see about. We got some good feedback on that first webinar, so we'd like to continue that as well. And then on the last slide, one of the other things that we alluded to in the presentation, or the information for this session, Sherry, if you want to pop that up quick, and see that we have some questions popping in here as well. And we'd ask you to continue to maybe now think about any questions that you have, and we'll start to answer those as well. If you do have questions that you prefer to send to either Sherry or I, there's our email address that you can forward those off to. Or if you'd like to get a copy of the case study that talks about another one of our customers with SOLIDWORKS that's doing this type of integration between 3D and the 2D electrical schematics, we have that prepared for you. Or if you'd like to see some of the things that we review for return on investment for companies that are looking to present this to management, you can also send me an email and I'll be happy to share that with you as well. Let's see here. We have a question that's come up here, a few of them. Sherry, can you see those or would you like me to read them off to you?
Yep, no, I got those here. It says, do you have to insert your own device catalog or does it come with most components out there? Does it update devices on its own if it's already come with devices in the library? And the answer is that our software actually comes in with over 500,000 manufactured library parts. We actually allow you, because of this, we don't want to increase the installation time, so we create catalogs of specific manufacturers. So that way what you can do is just simply open up just the catalogs that you are interested in, and then those libraries are then populated. They are also updated with every service pack that is received with electrical. It comes out at the same time. It is part of the installation manager of SolidWorks. So you will receive 5 different service packs in the year with those libraries updated. Hopefully that answers that question.
So 500, you said 500 manufacturers in there?
500, I'm not quite sure how many actual manufacturers catalogs there are, but a lot of the
components.
I'm sorry?
Is 500 components? You said
500,000 manufactured parts.
500,000. Yes. Okay. I'm going to sit down now and absorb that.
We are half a million, and I think that's growing. So, yeah, it's actually quite expensive. Another question is, can it split out a bill of material? Can it spit out a bill of material and a cost sheet as well? And actually, the answer to that is yes as well. The bill of materials is simply a report. Those reports can be exported through Excel or text or CSV files. And simply by a quick customization, you can add that report to have a cost sheet as part of it, but you would have to actually add your own cost to those components. Of course, your component price is different than another customer's, and so therefore those are not populated automatically.
I'd add on to that a little bit, Sherry. I just would add in there that we get that question a lot as well in the PDM side of the world for mechanical components. And we do have a way to address the cost information because it's not something that's static. It changes quite often. But typically the business system that keeps track of that is a company's ERP or MRP system. So we do have a methodology to connect that to your systems here if that becomes a critical thing that you would find value in doing.
Especially in electrical, it also has that ERP database connection directly.
Mm-hmm. Okay. Looks like one other question there yet?
Nope. I think we are all set.
Yeah, okay. Next one on our list is going to be a couple of weeks out here, right? For those that have been joining, you can sign up on our website. And I don't have that up in front of me what the next topic's going to be. Do you know it off the top of your head, Sherry?
Actually, the one that we are holding on June 19th. And that one here, I'm just pulling up the description here to make sure that I have it correct. And I can't find it at the moment.
Well, let's see here. I've got it.
Well, combining electrical, mechanical design expertise.
Okay, so that'll be when we talk more about the bill of materials.
Yeah.
So you want to come back for that one. And we
Oh,
appreciate
wait.
everybody's time.
No, no. Actually, Dennis, I need to correct us there. It is communicating electrical designs more efficiently. Our bill of materials is the following one.
Okay, my bad. So we'll be talking about a lot of the other exports and formats that you'll be able to use aside from just working between the two CAD systems. We're going to get outside of the CAD for those folks that that need your deliverable product, the end result here. So should be interesting as well. All right.
We'll hope to be seeing you then. Thanks for all joining us.
Yep, thank you. Have a great afternoon, everyone.